So this is the velocity. You can see velocity time graph, velocity along y-axis, time along x-axis. We got a graph straight line parallel to time axis. But here it starts from u. U is the velocity of the body. And as the time is changing, but velocity is found to be constant. So that is uniform velocity. There is no acceleration at all. Velocity is not at all changing. Velocity is not increasing. Velocity is not decreasing. It is constant. So velocity time graph for uniform velocity, not acceleration, children. Uniform velocity. This is not an accelerated motion. Body is moving with uniform velocity. So we get a straight line parallel to time axis. Children. So in this, how will you find the displacement from VT graph? See, how will you find displacement from VT graph? By finding area under this graph, shaded area you have to find out. This is the graph. This line is the graph. Area under that graph. Graph and this time axis. Area under this graph and the time axis will give the displacement covered by the body. So let us calculate area. Area is for a rectangle, area is length into breadth. Area is length into breadth. Length is 0 to t, time. 0 to t, that is t, time interval is capital T. And velocity, that is u. So u into t is the area of the rectangle. And we know velocity into time. When a body moves with uniform velocity, velocity into time will give the displacement. Velocity into time will give the displacement u into t. So area under the graph is u into t, that is the displacement traveled by the body. Velocity into time, that is the displacement. So in uniform velocity, when a body moves with uniform velocity, we can find displacement. Velocity into time will give the displacement. If we, from the graph, we just find the area under the graph. Area under the graph will give the displacement. Okay. So that is a 2-mark question. Draw a PT graph for a body moving with uniform velocity and find the displacement covered by the body. See, CBSE brought a new pattern this year onwards. Did you see? Anyone see that?
10, 12 teacher.
And 10, 12. And that will be applicable to you also because you are in 11th now. This 11th continuation is 12. So exam patterns may change, I think so. For you also. And I think it's good dividing into 2 parts. Only half part you have to study first half, and next half you can study in the next half, like that. Isn't it good, children? What do you think? Altogether?
Online class.
Yes, that's better. That is why they changed the pattern. Because it is online classes now. Next is very important relation deriving the 3 equations of motion, and this video I put in the video class. I put in the group, children. Please watch that because that will be more, I think so. It will be more effective for you. And after watching it, you please in the comment you can write. You can write your name. Watch those who watched, please write your name. That will be better. Then I can understand how many of you are watching it. See, when we take effort to take the video, upload the video, all such things, when we take, it must be useful, no, children. Very few are watching. That's the main problem. Everybody should watch it. Otherwise, only to show this picture and explain, no, that's enough if you are not watching it. So we can derive the equations of motion. So I will show another graph. Okay. Danish is waiting. How many? 36. Okay. So this is what we have seen now. The body is moving at constant velocity. Area of the rectangle will give the displacement of the body. A displacement is equal to area. All of you understood this, children? Please respond.
Yes, Miss.
Okay. Next one we can see. Next one. See,
V naught and the difference.
here, just by seeing the graph, you have to tell the nature of motion of the body. Okay, I will ask questions to you. Adinant, is the velocity increasing from this graph? Tell, Adinant. Adinant, tell. You see, you have to respond, otherwise you will not get mark.
Yes, teacher.
Is the velocity increasing with time?
Yes.
Is it uniform or not? Straight line inclined to time axis. Is the body moving with uniform acceleration? Is the velocity changes are equal in equal intervals of time? Straight line inclined to time axis. Can you tell? Don't know?
Read, teacher.
Okay, no problem. One part you told velocity is increasing. At least you are knowing that. Then I will ask to another one. Amina, what type of motion is this? Straight line inclined to time axis. Velocity time graph. You have to respond fast. That's needed. Otherwise, we will lose time. Amina? Amina, no mark. 2 mark gone. You are not at all responding. Otherwise, I would have given another choice. No response, Amina. I don't know what she's doing there. Aishwarya, can you tell what type of motion is this? Aishwarya?
Yes, teacher.
What type of motion? Accelerated motion or uniform velocity motion? What is this? What it shows? Is the velocity changing, increasing with the time? See, just to
Yes,
see this.
teacher.
Under time here, velocity here. Time here, velocity here. Time here, velocity here. Is the velocity increasing?
Yes, teacher.
Is it uniform? Increase in velocity, is it uniform?
Yes, teacher.
Yes. So, so it is a uniform velocity motion or a uniform accelerated motion? Tell.
Uniform velocity.
Uniform velocity means velocity is not changing.
Uniform acceleration.
Velocity here, velocity is changing. So it is
Yes,
not a uniform velocity motion. Okay, it is not a uniform motion. Velocity is increasing uniformly. So what type of motion?
Uniform
Aishwarya?
acceleration.
Uniformly
acceleration.
accelerated motion. Uniform. Aishwarya got answer. Okay. So you will be getting the mark. Okay. Aishwarya. Every day I will ask question and we have to give mark also. Anyway, you have to respond. That's the main thing. Some children are not at all responding. So here we got a uniformly, just by seeing the graph, you will be able to tell this is a uniformly accelerated motion because this is a straight line inclined to time axis. Velocity time graph is a straight line inclined to time axis. So that is just, if it is a curve, you cannot tell it is a uniform acceleration. It is a straight line inclined to time axis and it is upwards. That inclination is upwards, so we can tell velocity is increasing. So positive acceleration. If it is downwards, you can tell it is negative acceleration. Uniform itself, but negative. If it is downward, inclined, but downward, we can say the velocity is decreasing with time. But here, the velocity is increasing with time. So it is a uniform accelerated motion. Okay. Then we know area under the graph gives, I will ask to the next one. Area under that graph, one graph is plotted there. Area under the graph gives, Devi Krishna, area under the graph gives, Devi Krishna.
Yes, sir.
Area under the VT graph gives what? Area under the VT graph. VT, what is meant by VT? Velocity, time. You don't know?
Teacher.
No. Did you watch the video I sent you yesterday? No. That's why. Fatima, Shasha. Fatima.
Yes,
Area under the graph gives what? Area under VT graph. Don't know. Fatima. Area under the VT graph gives what? Just now I explained one graph now. Area under the graph we got. What we got? Don't know. Okay. Midul. ഫാത്തിമയ്ക്കും അറിയില്ല. Midul. Area under the graph gives what? Cover ഉദ്ദേശിക്കുകയാണ്. Very good. Midul told the answer. Displacement. Area under this graph gives displacement. Correct. Midul's answer കിട്ടി. Before you will be getting the mark. Okay. I will note these names. Okay. So area under this graph. Graph is this line. Area under this part, shade this area. That is the displacement covered by the body. We are dividing this into two parts. You can see, children.
Between t and 0. The value of a dash is equal to acceleration. When acceleration...
Okay, I will ask another question. At a time t equal to 0, what is the velocity? Naja? Time t equal to 0, what is the velocity? Naja? Time t equal to 0, velocity is v0. Correct. V0 ആണെന്നാണ് പറഞ്ഞത്, അല്ലെങ്കിൽ v0 എന്നാണ് പറഞ്ഞത്?
Equal to 0.
Time t equal to 0, what is the velocity of the body?
Teacher, 0.
0 അല്ല. Look in the graph. Time t equal to 0, what is the velocity? 0 ആണെങ്കിൽ ഈ എൻഡ് ഇവിടെ ഇരിക്കണം. മനസ്സിലായോ? This end must be touching this origin. So when time t v0 ആണ് കേട്ടോ. v0. Time t equal to 0, velocity is not 0. If it is 0, graph will be here. This point will be here. Understand? So this is a okay. Here. Okay, this is C. At time t equal to 0, velocity is v0. At a time t equal to t, what is the velocity? I will ask to Muhammad Nidal. T at a time t, what is the velocity of the body? At a time t time, what is the velocity of the body? Nidal. Answer. Parthiv.
I don't know, teacher.
Parthiv, can you tell? Parvana. Parvana.
V0 t.
At a time 0, velocity is v0. At a time t, what is the velocity? That is the question. Mic is not working. Parvana. Not able to hear. I'll ask you another one. Varsha, tell. At a time t, what is the velocity from the graph? See, it is visible in the graph. Everything is written in graph. At a time t, what is the velocity? Varsha, tell.
Velocity v.
Correct answer. Velocity is v. So Varsha got answer. So at a time t, velocity is v. At a time 0, time t equal to 0, velocity is v0. And that is why this is called initial velocity. Initial velocity means velocity of the body at a time t equal to 0. When we start it, when we start the motion, it's already having some velocity v0. And after moving certain distance, velocity increased to v. That is, this is just by seeing the graph, you should be able to explain all these things. At 0 time, velocity is v0, and body is moving with uniform acceleration. It is a straight line. After a time t, velocity increased to v. So what is the change in velocity, Vaishnavi? What is the change in velocity in a time interval t, 0 to t? In a time interval 0 to t, what is the change in velocity? Vaishnavi? Vaishnavi.
v0.
V minus V0. Correct answer. Change in velocity is V minus V0. Correct answer. Then we can find out the acceleration. What is the equation for acceleration? What is the equation for acceleration? I don't know.
Velocity by time.
What's your name? Tell.
Devi Krishna.
Devi Krishna. Okay. Change in velocity by time. Devi Krishna. Change in velocity by time is acceleration. That is written here. Average acceleration is change in velocity v minus v0 by time interval t minus 0. So we got acceleration. Acceleration is equal to change in velocity by time. Okay. Now we got that. Okay.
Is constant. By cross multiplying and rearranging, we get the value of velocity as the sum of v naught and the product of a and t. This is equation 1 of motion. The second equation represents the relation between...
Okay, children, this is the first equation of motion. Acceleration is equal to change in velocity by time interval. Cross multiplying, we get a into t equal to v minus v0 or v equal to v0 plus at. Velocity time relation, very, very important relation. Velocity time relation. This relation you have studied in 9th standard. V equal to u plus at. U is the initial velocity, a is the acceleration, uniform acceleration, and v is the final velocity. It is the time taken to change that velocity from v0 to v. Okay, everybody understood this equation, children?
Yes,
Ma'am.
Okay. Change acceleration, very important. When I ask what is velocity time relation, you have to tell this equation. Velocity time relation. V equal to u plus at. Instead, here we study v equal to v0 plus at, because in your textbook it is written like that. Initial velocity is denoted as v0. v0 means initial. Time 0, velocity v0. Velocity is not 0, children, it is v0. Where value is there? You start with a velocity 30 meter per second, like that. It is not starting from 0. It is already having a velocity 30, like that. Finally, it reached to 60 meter per second. Velocity increased. Okay. So one relation we got. Next relation.
Displacement x, initial velocity v naught, acceleration a, and time t. The area under the line PQ up to the x-axis represents displacement x. Displacement x is represented by the area between the lines joining points O, P, Q, and S. This is equal to the sum of motion. Let's now use calculus to derive the equations of motion that were derived.
Okay, another equation we can derive average velocity equal to average. See, initial velocity v is 0, final velocity v. Body is moving with uniform acceleration. Then average velocity. Average means we have to find the mean of that. V plus V0 by 2. That is average velocity. When this you can use only when body moves with uniform acceleration. If it is non-uniform, please children don't use this equation. Non-uniform. This is a uniform accelerated motion. Uniformly accelerated motion, you can find average velocity by this formula. Initial velocity plus final velocity by 2. That will give average velocity. Then here, displacement will be average velocity into time. And we know this equation time equal to v minus v0 by a. Average velocity v plus v0 by 2 and time we know from v minus v0 by a. From which equation? V equal to v0 plus at. From that equation t you can take. So v minus v0 by a it will be. So just substitute that displacement equal to average velocity into time. Average velocity, here it is, you can substitute into time. Time is this one. From first equation we are writing time and that we substitute here. So a plus b into a minus b form it is now v plus v0 into v minus v0. That will be v square minus v0 square, a square minus b square. A plus b into a minus b, a square minus b square, like that. V square minus v0 square by 2a. So we can rearrange the equation. You can see rearranging.
So far, using basic mathematics.
Yes, so these are the three equations. Two equations we have derived. One is this last equation we got, and this one also is there. That we also
The new set
have.
of equations.
Okay, that we can derive, children. One more equation we have to derive. Two equations we derived. That I will show you from my notebook. See, one equation we derived a equal to v minus v0 by t minus 0. That is also equal to slope of the graph. So we know slope of vt graph is acceleration. That also we know. Slope of vt graph. What is slope of xt graph, children? Slope of xt graph. Anyone? xt graph in the slope endanu? What is slope of xt graph?
Velocity.
Very good. What is your name?
Krishnapriya.
Krishnapriya, very good. Krishnapriya. Slope of xt graph is velocity. Krishnapriya. See, for your response, you will be getting mark. Every day's response you have to write. Now, it is the criteria for giving the internal mark, children. Okay, slope of vt graph is acceleration. Slope is equal to, here you have to mark the angle theta. So tan theta you will get the slope, tan theta opposite side by adjacent side. Opposite side is v minus v0, adjacent side is this difference, t minus 0, t minus 0. So we got this, v minus v0 equal to at, therefore v equal to v0 plus at. We got that equation. V equal to V0 plus at. Next is area under the VT graph represents the displacement. Area. Area, how will you find this graph? You see two figures you can see, geometrical figures, area under this graph. One is the rectangle and the other is the triangle. Triangle area formula, Chandana, what is the area of a triangle formula?
Half BH.
Very good. Chandana. Half BH. So here, Chandana, you have to tell what is the base here. This
Rectangle.
base, see this triangle. This is triangle. Oh,
Base T.
D minus T minus 0. Please unmute. Okay. Varsha is not there. My mic is not working. Okay. So area of the triangle plus area of the rectangle will give the total area under the graph. Area of triangle, how will you find? Base into base is this difference, AC. AC means time interval, T minus 0. This is T minus 0. And height is V minus V0. So half into T minus 0 into V minus V0, half base into height. That will give the area of the triangle. Then what is the area of the rectangle? Diba. Area of rectangle, how will you find? Diba.
Teacher,
Area of rectangle.
Ciscoല് മൈക്കോണോ ഇല്ലാന്ന് പറഞ്ഞു.
ആണോ? Okay. Then I will ask to another one. Okay. Ayush, tell. Ayush, area of the rectangle. How will you find Ayush? Ayush. Length into breadth. Here in this triangle, how will you find length? Which difference will give length, children? Ayush, tell. This triangle ACDO rectangle. What is length? Tell. Ayush. സ്ക്വയർ പോലെയാണ് ഇരിക്കുന്നത് അല്ലേ? ഓക്കെ. എ ആണെങ്കിൽ എ ഒന്ന് എടുക്കാം. ഇൻറ്റു OD അല്ലേ? അപ്പോൾ AO means what is this? Tell. From this is a velocity time graph. So OA means how much it is? What is written here? VO means V0, V0 എന്ന് പറയാം. V0. Okay. That means the velocity at the time t equal to 0, initial velocity V0. And what is this difference? Here it is written t, small t you have to write here. Small t is you have to write here. So t minus Ayush, tell. T minus O. O എന്ന് പറഞ്ഞാൽ 0 ആണ് ഇവിടെ കേട്ടോ, ഒറിജിൻ ആണ്. ഓക്കെ. T minus 0 ടൈം ആണ്. അപ്പോൾ T is the time. അപ്പോൾ V0 into T gives area of this rectangle. V0 into T gives area of the rectangle. Okay. Ayush, understood?
Teacher.
Then we can see that how they determine that. See, V0 into T, area of rectangle. Area of triangle, half into V minus V0 into T. Clear, children? This step?
Yes,
Clear?
teacher.
Okay. V0 into T plus half. And this equation we substituted from here. What is V minus V0? This is taken to left side. What is V minus V0? 80. Correct. 80. That 80 is written here. V minus V0 equal to 80. Into T already there. Into T. Upper 80 square. Half 80 square we get. So we got see x equal to V0 T plus half 80 square. That is equation number 2. So this is similar equation you have studied. S equal to UT plus half 80 square. See, these children by heart study these equations. Don't make any mistake. At the next day I will ask children all these 3 equations. Very important relation. X means what, children? X means what? Displacement. Displacement. Yes. V0. Initial velocity. T. Time interval. A.
Acceleration.
Acceleration.
Very good. So now we have derived the three equations of motion. Very important relation. You have to derive and study. Draw the graph. Explain the graph. How will you explain the graph? Let me see how you are going to explain the graph. That explanation is written here. Ganda. It's explanation. So in a derivation question, what you have to do? First you have to draw, if figure is there, first you have to draw graph, and which all letters you have used here. V is there, V0 is there, T is there, V minus V0 is there, what this AB is there. So first you explain the graph. AB is a graph, VT graph, and its initial velocity. Body is moving with initial velocity V0, moving with constant acceleration A, and finally it reached velocity V at a time T. All these things you have to explain. That is the explanation of the graph. And displacement, S is the displacement, that is the area under the graph gives displacement. Slope of the graph gives acceleration. VT graph, slope of VT graph gives acceleration. Area under VT graph gives displacement. So all these points you have to explain. Okay, that is the explanation of graph. Velocity displacement relation. X is the displacement, velocity is there, initial final velocity, initial velocity, uniform acceleration. X is the displacement. Velocity displacement relation. V square equal to V0 square plus 2AX. Okay. Similar relation that you, so these are the three equations of motion. Kinematic equations of rectilinear motion for constant acceleration. Children, when a body moves with constant acceleration, you have to use this equation. And I have seen children using the same relation, velocity into time, displacement equal to velocity into time. Even though when body is moving with constant acceleration, children are using that formula, then your answer will be wrong, children. Displacement is velocity into time. You can use only in, please complete. Displacement equal to velocity into time. That relation you can use only when body moves with. Children, complete. Uniform motion, uniform velocity. What is your name? Nayana, very good. Nayana. So Nayana answered, when body moves with constant velocity, uniform velocity, then only you can use that formula. Whenever we mention which formula, velocity into time, displacement is velocity into time, that you can utilize only when body moves with uniform velocity. But when body moves with a constant acceleration, we have to use these three formulas. Understand, children? Clear? Will you make mistake? That is the main difference, uniform motion and uniform accelerated motion. These are the formulas you have to use. And some extensions are there in the earlier three equations. Suppose the body start from not from 0. As we here the body started with velocity v0 at time t 0. Similarly, if body start from another position other than origin, we have to add this distance also, x0, time t equal to 0, body is not at origin, it is already covered some distance x0. So that also you have to add with this equation. For example, suppose you are going to your school and you are, suppose your bus stop is 1 meter away from your home. So, and then you travel in a bus with uniform acceleration. So, the 1 kilometer is distance from your home to bus stop. That you have to add how much distance bus traveled to reach there. From the bus stop to school, how much distance it traveled with a uniform acceleration it is moving. So this will give that distance, bus stop to school, that distance it will give. But you know, initially there is a distance from your home to the bus stop. That distance you have to add to get the final displacement, final position. from your home to school. So initially there is a distance from your home to bus stop that you have to add, plus this distance when body moves with a uniform acceleration. That's why we add x0 with this. Understand? So here another, similarly here also, if there is some initial distance, you can use v square equal to v0 square plus 2a into x minus x0.